We're now going to start the simulator and demonstrate the basic functionality of using a logic simulator. Currently, the Vivado tool is in the project manager mode, and you can see this by the blue bar at the top indicating project manager for the 4 functions. I'm going to run the simulator, clicking Run Simulation, Run Behavior Simulation, and the Vivado tool will then move away from the project manager into the behavioral simulation. I can tell I'm in the behavioral simulation by the blue bar up above. In Vivado, anytime you execute a command with the GUI, there's also a corresponding tickle command that you can execute on the command line. I can start the simulator as I did with the GUI buttons, or I can run a command that's shown here called, scrolling up, Launch Simulation. The graphical user interface for Vivado is now different. On the left, the flow navigator is the same, but everything else has changed. The toolbar at the top has changed to represent the tools available for the behavioral simulation, and also the components here in the middle of the user interface. In this box, I have what's called scopes. This describes the various modules that we have within our design that we can examine. We currently only have one for functions, and this GLBL is the global library. We have the objects pane, and in this pane, we have all of the objects within the selected 4 functions module. These objects include my inputs, my outputs, and intermediate signals. Inside this pane, I can see the current value in the simulation of these signals and its logic type. We also have the waveform view. This view is probably the most important, the one we'll spend most of the time, and I'm going to resize a little bit so that I can make more room. Some people will actually close the objects and the scopes view to give more room for viewing. In the waveform view, we have a set of tools just for the waveform. We have a list of signals and signal values, and then we also have the waveform area where the waveforms themselves will be drawn. You'll notice here that my signals have values. The inputs have the value Z. Z means high impedance or not yet set, and X is unknown. Later, I will be changing these values to provide a more useful result. We also have a tickle console in the simulation view, just like we did in the project manager, but we'll use the tickle console quite a bit in the simulation view. We're going to begin by performing a simple run simulation. Up here at the very top are a number of buttons that you use to run. This button here is the run for a specific amount of time. I've got a 10 nanoseconds. When I press this, the simulator will run for 10 nanoseconds. When I've done that, you can see that the corresponding tickle command, run 10 nanoseconds, is shown. And I could call it the same functionality by just typing in run 10 nanoseconds. Notice here that in the waveform, lines have been shown, and these lines show the values of the various signals. These 3 blue values represent the Z of my inputs, indicating that they have not been set. They're in between a 0 and a 1. And the red indicate X's, or unknown values. Typically in a simulation, when we see blue or red, that means there's a problem. In our case, there's a problem because we have not yet set the inputs of the simulation. So I'm going to do that now, but before I do that, I want to reset the simulation. I can reset the simulation to time 0 by pressing this button right up here, or correspondingly typing in the tickle command restart. So before I issue a run, I'm going to set the value of each of my inputs to 0. So I'm going to left click A, right click, force constant, force value 0. And notice that the corresponding command has shown. We've got an add force command. I'll do the same thing for B, force it to the value 0. And again, the command shows up. And then for C, I'm going to type in a tickle command by hand. Add force. I'm going to put the name C. I don't have to put the full path of 4 functions in this case because the top level function is 4 functions. And I'm going to give it its value 0 and have it change at 0 nanoseconds. I don't have to indicate the dash radix hex. This is a single bit value, and this will be sufficient. So at this point, I have assigned the values of the 3 inputs. And now I can perform a run. I'm going to type in run 10 nanoseconds to cause the simulator to run for 10 nanoseconds. Notice in this case that when I simulate, my output values are green, indicating that I had a good run. If I want to look at the full, in the top bar I have from the time, it's 10 nanoseconds, and so I want to zoom out all the way, and I'm going to click on this Zoom Fit button, and this gives me the full simulation value. Notice here that A, B, and C are 0, and my outputs are 0, 0, 0, and 1. At this point, I've only simulated 1 values for my inputs. I'd like to simulate other values as well. So I'm going to add another command to change the value of A to 1 and leave the values of B and C the same. I'll run for 10 more nanoseconds. Zoom out. And you'll notice here that from 0 to 10 nanoseconds, I have 1 set of inputs and 1 set of outputs. From 10 to 20 nanoseconds, I have a different set of inputs, and my outputs have changed. And I'll run yet another command. I'll add force B 1, 0 nanoseconds. Run for 10 nanoseconds. Zoom fit, and here I have 3 sets of values, and my circuit is operating as it should. When you have a waveform typically like this, you'll have lots of signals and lots of signal transitions, and it can be difficult to manage it. So there's a couple important tools that you should learn. First, as we said, there's the zoom fit, and this will zoom all the way out so you can see the entire waveform. We can zoom in with the magnifying glass and the plus, zoom out with the magnifying glass minus. We can also select, zoom fit, I can select certain transitions with the mouse, and the cursor will tell me exactly where this transition occurs. I can move the cursor to 0 by pressing this button, move the cursor to the end by pressing this button. I can select the cursor and then center the waveform with this button. I can also select a signal and move to the next transition to the right with this button, move to the next transition to the left with this button, and so on. Sometimes you'll want to zoom into a region of the waveform. So if I zoom back out and I want to zoom in here, I can left click and drag with yellow. It will zoom in that region of the simulation. When you do large simulations, it's difficult to manually type in the values of all of your inputs. And so we'll write a script, or we'll create a file where we add force commands and run commands to simulate a pattern of inputs. So I have created a file called simulation.tickle in which I will source. So I take source, simulation.tickle, and it will run a large set of inputs that I've already typed in. If I zoom out, you can see I have tried all values of A, B, and C, all 8 possible inputs for A, B, and C, and then I can go and check the values of each of my outputs in each of these conditions. Sometimes we may not want all of the waveforms. These signals here are the intermediate signals of my Verilog circuit, and I can delete them if they're cluttering the waveform by selecting the signals, right-click, and delete. And if I want to add them at a later time, I can select the signals here in the object view, right-click, add to waveform, and they can come back. When I'm done with the simulation, and I want to exit the simulator, I can click the top right button here, close, OK. I will discard any changes to my waveform. I don't need to save these. And I'm back to the project manager. Notice that I don't necessarily need to click the top right button, and there's a command called Close Sim that can be used to close the simulation. With this tutorial, you should have enough information where you can complete the simulation for this lab.